we have to look at degrees, right? So if you understand that, we are going to make a bit of reminder on that. This particular thing has degree 1, right? The degree of this. So let me put it like d equals to 1, right? We know because the greatest power of x here is 1. Here, x squared plus 2x minus 5. The degree for this is 2, right? So because the greatest power on the x for this one is 1, but for this one is 2. But among the powers on x, the greatest one is 1, and that becomes the degree. So the focus is going to be, I want you to know that these ones that are having degree 1, expressions of degree 1, where the greatest power on the x is just 1, if nothing is written, the meaning it is 1, those ones are called linear expression. But in this particular rational function, we are going to call them linear factors, right? Those are linear factors. If you see something like normal x alone as an expression, this is a linear factor because in this entire expression, the greatest power on x is 1. If you have x plus 3, this is a linear factor as well because the degree of the expression is 1. If you have x squared plus x, this is not a linear factor because the greatest power on x is 2, right? That becomes the greatest power. So if I have something like just 3 where there's no x, this one is not a linear factor, this is a constant factor. So the focus is on linear factors where the expressions, right, they are either just x or they are x plus 3 or x plus something. Those ones are linear factors. So the focus is going to be on linear factors. So in order to do rational functions, so what we are basically doing in partial fraction is that, remember when we're doing addition of 2 over x plus 1 plus 3 over x minus 5, for example, right? We converted this thing together to have a simple response at the top. So there's a particular response at the top, right? Something, some answer, so we will have a finite numerator over maybe the denominators x plus 1 multiplying x minus 5. Then when we do the cross multiplication and everything, we have something at the top over the denominators multiplying each other, right? So for partial fraction, what we are basically doing is that we are moving from an expression like this, an expression of this sort, back to something like this. We are now going to make it partial now, right? Basically, allow me to say we are going to partialize it, right? So we are moving from something that is already added or subtracted to something that was initially uh, separated, right? That's what we are doing with partial fractions in basic term. So it's like converting something that is already added to something that is separate, expressions that are separate, but they are all partial fractions. So let's look at some examples. So we have this one added right now over here, right? We are going to separate it to get the partial one, so the partial fractions, right? So what you do is that you have to focus on the denominator. So the denominator is going to be our main focus. You see, the denominators are factors multiplying. This is one factor multiplying another factor, right? So those factors, you need to check if those factors are linear factors or not. For this particular lesson, the focus is going to be on linear factors, meaning the degree of each factor is going to be 1. So these are for the linear factors. So for linear factors in general, right, what we do is that we are going to make them identical to some expressions on the other side because we don't know what they will give us. For example, when we give something like this, like if I have 2s plus 5 all over s plus 1 multiplying s minus 5. This one, we don't know what they will give us. So, right, this one can be equal to some a because this one alone can be under one factor, right? S plus 1 plus another number will be here, x minus 5. So the denominators are different, right? And that they are separate fractions. So for linear factors, what is basically do is that let's write the expression first, s plus 1 all over x plus 1 multiplying s minus 2. So for linear factors, what happens for linear factors is that we are going to separate them, put how do you call it? Let me say variables, but these are going to be capital letters, right? Aside x itself. Capital letter, we are going to usually start with a. So let's say some a all over the first linear factor, x plus 1 plus b as numerator over the second linear factor. This is what we have in general. right? This is how to express this in partial fractions, right? So we are going to solve for the values of A and values of B. We recently did about the expressions for um, identity, using identity. We saw something like that. So, right, in this section, we are going to just focus on how to separate the linear factors first, right? So let me take another example. You see this one, for example, 5 over this, right? So we have 5 over x minus 1 all over x plus 3. This is one linear, this is having two linear factors. Because the linear factors are to this is 1. We are going to have a as a numerator on the first linear factor plus b over the second linear factor, which is x plus 3. So this is the expression for it. We will come back and solve for the values of a and b actually to get them. But then we need to actually understand how we are going to express these expressions into partial fractions. So this one as well, we have s squared. Numerator, we don't worry much about the numerator now, right? All over x minus 4 all over x plus 5. So this one, we might be tempted to directly go and also do the partial fraction thing, right? So generally what we have to do again over here is just a over x minus 4 plus b over x plus 5. So the degree of this one is 1. The degree of this one is 1. So the total degree of the denominator is what? 2. So you add them. So the degree of the first linear factor is 1. The degree of the second linear factor is 1. The total degree of the denominator is 2. Look at the numerator. The total degree of the numerator or the degree of the numerator is also 2. So it's a partial fraction that is in such a way that the degree of the numerator is not less than the degree of the denominator. For such a case, we have to do long division first. So we will come back to that and do that very well. But right now, I want to draw your mind to that. Also take note that you can only do partial fractions after you have checked if long division is possible or not. So the very first step is to check if long division is possible or not. So you do the long division before you do the partial fraction. Partial fraction is done on expressions or rational functions that's in such a way that it is proper rational functions. Proper rational functions. You use those terms in the past. But right now, so for this one, you have 2x plus 3 all over x minus 1 multiplying x plus 2 multiplying x plus 4. These are the denominators, right? And we have 3 terms at the bottom. So this is a linear factor with degree 1, degree 1, degree 1. The total degree of the denominator is 3. Or the degree of the numerator is also 1. The degree of the numerator is also 1. We can see that the degree of the numerator is less than the degree of the denominator. For that matter, we can proceed directly and do a over the first linear factor at the bottom, s minus 1, right? We are done with that one. Plus, the next one will take a numerator of b, which is s plus 2. Plus, the last one is c, abc. So the numerator is going to be like abcd like that. X plus 4. For linear factors, you just distribute them under the variables as numerators, right? Each expression or each linear factor should be under one numerator, basically. So if I have another example that, let me give something like this. If I have an example that is such a way that it is, let's say 2s plus 1 all over x multiplying x plus 3. For example, you can see that this one alone, x alone standing on its own, is one factor. It is multiplying another factor. This x alone can be written as x plus 0 multiplying x plus 3. This can be written like that. So if you see it standing alone, it is the same as x plus 0 multiplying something. So this one alone is a linear factor. For that matter, if you have just x alone, it's considered a simple linear factor. So that's going to be a over x, because that's the factor, plus b over the second factor, x plus 3, right? Yes. So this is how to write the various linear rational functions, right? Is with linear factors. Now, in the next session, we are going to solve the actual values of a and b and write the rational functions again, right? Yes.